Hello. In this video, we're going to do some homework problems from parallel circuits. All right, so the first thing that we have to do, or that I want to do today, is go over the formulas. So let's first draw a parallel circuit. Here's a power supply. And in order for two resistors to be in parallel, they both have to be touching the same node on each side. So if we had, let's say we had a circuit like this. Okay, so here is our circuit. And let's say that we have something else like this. So in order for them to be in parallel, both sides need to be touching the same, need to be together. I don't know, that's not a perfect definition. But if we look here at these two circuit examples, and we look at the different resistors, so this resistor is touching this node on this side, and this resistor is touching this node on this side. And then on the other side, this resistor is touching here, and this resistor is touching here. So they're both touching the same. So these two are touching the blue node on that side, and they're touching the green node on this side. So in order for them to be in parallel, they both have to be touching. So here, these two are in parallel. They're both touching the same nodes on each side. Okay, so if we go over to this circuit, we have a lot of different resistors. Let's put some things on here. So this is going to be 1, 2, 3, 4, 5, 6, 7. Okay, so we're trying to figure out what is in parallel. So if we look here, so let's look at 1 and 2. So 1 is connected here, and 2 is connected here. So this would be one of our nodes. Okay, now I'm going to go through and draw all the other nodes in different colors. So this is a node here and here, and this is a node here and here. This one would be here. So what we're trying to show is that all of the different connection points that we would have. So this would be a node. This is a node between those two. And finally here, this would be a node here connected. Okay, so when we look at what's in parallel for the circuit, let's look at 1 and 2. So 1 is connected to the green on one side and orange on the other side. So are there any other resistors that are connected to green on one side and orange on the other one? So it looks like R1 and R2 are in parallel. Okay, so now let's look at R3. R3 is connected to orange on one side and dark blue. Are there any other resistors that are connected to orange on one side? Well, these two are connected in orange, but then they're to green, they're not to dark blue. These resistors here, 4, 5, and 7, are all connected to dark blue, but none of them are connected to orange on the other side. So 3 is not in parallel with anything. Okay, so let's look at 4. 4 is connected to dark blue on this side, and it's connected to brown on the other side. Is there any other resistors that are connected to dark blue and brown? So 3 is connected to orange, that's not to brown. 5 is connected to light blue. 7 is connected to blue and brown, so 4 and 7 are also in parallel. So when we look at these resistors, they have to be connected to the same thing in order for them to be in parallel. If we were looking at this in terms of series circuits have only one path. So this would be a connection point where there's no dots, because dots are branches. And so the only spot here that has a series circuit where there's only one wire between the resistors, so if we look here, R1 is connected to a dot, not in series with anything. R3 connected to a dot on both sides, not in series with anything. 4 is connected to a dot. The only ones that have a series path would be 5 and 6. So R5 and R6 in this case would be in series. Because they're still connected to a dot on one side, but they're not connected to a dot on both sides. So having the dot on both sides is the problem there. Okay, so one of the things that's going to come up throughout the class is how do we determine what's in parallel and what's in series, and so we'll have to kind of keep working on that. So those two would be series. We looked here. These two are parallel, and then 4 and 7 are also in parallel. Okay. The other ones we would say are not in series and are not in parallel with other things. So like 3 is not in series or parallel with anything. It can't be simplified down that way. All right. So now let's look at our formulas that we're going to use for parallel circuits. So here I'll draw a parallel circuit. So we have R1, R2, R3, and V total. So the thing that we always want to remember for parallel circuits is that the voltage is the same. So when we're looking at our formulas for parallel, V total is going to equal V1, which is going to equal V2, which is going to equal V3. Okay, so the voltage across all the components is the same. The total current is going to equal the sum, so that's going to be I1 plus I2 plus I3. Our total, we're going to use the formula, R1 to the negative 1 plus R2 to the negative 1 plus R3 to the negative 1. And then power total is going to equal P1 plus P2 plus P3. So if we look here, the current is the sum, the power is the sum, the voltage is equal. Okay, so parallel circuit voltage is the same, current adds up, and power adds up. All right, so let's do an example problem. Okay, so here is our first problem that we're going to do. And we'll start off with one with 2 resistors. So we have R1 and R2. We'll make R1 100 ohms and R2 200 ohms, and then let's make the voltage supply 40 volts. All right, so the first thing that we're going to do is put in a table. So we'll put the table at the bottom. And in the table, just like the series circuits, we're going to have voltage, current, resistance, and power. We have R1, R2, and total. Okay, so we'll start off. Here's going to be our steps. All right, so step 1, fill in the table of what we know. So we know that the total voltage is 40. We know that the resistance R1 is 100 and the resistance R2 is 200. The next thing that we're going to do is circle things that are the same. All of our parallel circuits, the voltage is the same. So we'll circle all the voltages. Okay, so that means that we can write that it's 40 volts here and it's 40 volts here. The next thing that we're going to do for this problem, number 3, is find the currents. Find all the currents. So we'll start off with I1, which is going to be V1 divided by R1. So we have 40 divided by 100. So that's going to equal, let me do that on my calculator. 40 divided by 100, and that's going to be 400 milli. So I'll put that in here, 400 milli. I2 is going to be V2 over R2, so that's going to be 40 divided by 200. And that's going to be 200 milli. So put that in here, 200 milli. And then the total is going to equal I1 plus I2. So we'll have 400 milli plus 200 milli, and that's going to be 600 milli. So we have 600 milli there. All right. Next thing we'll find is number 4 here, is find our total. There's 2 ways to do our total. So the first way we'll do is V total divided by I total. So if I take 40 divided by 600 milli, I'm getting a little sloppy here. Let me try to write this again. So 40 divided by 600 milli. So let me do that. 40 divided by 600 milli, and I get 66.7 ohms. The other way to do our total is to do the inverse of the sum of the reciprocals. So I'm going to do 100 to the negative 1 plus 200 to the negative 1, all to the negative 1. And I would recommend practicing this when we do these problems, just to make sure that you're good at it. And that also will equal 66.7 ohms. All right, and then the last thing that we're going to do for this problem is find the powers. So this is going to be my step 5 over here, is going to be to find all of the powers. So P1 equals V1 times I1. So I'd have 40 times 400 milli. And so let's punch that into our calculators. And for that, I get 16 watts. P2 is going to be V2 times I2. So that's going to be 40 times 200 milli. And that'll be 8 watts. And then P total is going to be V total times I total. So that's going to be 40 times 600 milli. And that should be 24 watts. Okay, so we have our table here. So now what I'm going to do is I'm going to open up Excel. So here I have Microsoft Excel spreadsheet. And what I'm going to do is I'm going to put in this box resistor 1, Now in Excel up here, I can make the cells bigger. If I grab this corner here, it'll make this one resistor 2, so I do that. And then I'll write in total. Okay, I'm going to make up a table just like the one that we have. This is going to be voltage, current, excuse me, I'm getting ahead of myself, resistance, and power. Okay, so I'm going to make these a little bit bigger, and then I'm going to zoom in a little bit so we can see this better. I'm going to highlight the whole thing and turn it into a table. Okay, so here is our Excel spreadsheet that we're gonna use. Okay, so the first thing we'll do, and we'll follow the same format. So what do we know? This is 40. Okay, that was the given, and then we have a resistance of 100 and a resistance of 200. Okay, so now let's make all the voltages equal. So I'm going to say equals, and then click on this cell, and then hit enter. Equals, click on this cell and hit enter. And I don't like that all of these aren't centered, so I'm going to do that. And these ones I'll make justified to the right. Okay. Now, current. Current equals the voltage divided by the resistance. So then I hit enter, and I get 0.4. I'll drag this down, which will make the formula follow to the next row, 40 divided by 200. And then for this one, I'm going to say equals, and then this is the sum. So I type in sum, parenthesis, close the parenthesis, hit equals, and it adds it up. The resistance, this is going to equal the voltage divided by the current, and I get 66.7. And then for power, that's going to equal the voltage times the current. So I get 16, and then I'm going to drag this down, and this one is 40 times 0.2, and this one is 40 times 0.6. So now in Excel, I've made this table, and let's check to see if it matches up with what we had. So if we look here, we had 40 for the voltages, current, 0.4, 0.2, 0.6, that's the same as 400 milli, 200 milli. The resistances, 100, 200, 66.7, and then the power, 16, 8, and 24. So we are good. Okay? All right. So now let's go and do another problem. So for this, actually, just a sec. So one more thing I want to put on here is we always are concerned about the current, what the current's doing. So let's draw the current on here. So we have current here, this is the total. This is going to be 600 milliamps of current. It's going to come into this node as 600 milliamps, and some of it's going to go up, and some of it's going to go this way. And so the current that goes to the right, it's based on the ratio of these resistors. More current goes to less resistance. So we get 400 milliamps here, and we get 200 milliamps here. And then that 400 milliamps goes through the resistor, and it's still 400 milliamps. This current, this 200 milliamps, goes around the corner, goes through this resistor, goes around this corner, and it stays 200 milliamps. Then the 400 and the 200 get combined back together, and we get 600 milliamps. And so this is the path of the current flow. All right, let's go to the next problem here. Okay, so for this problem, this time we're going to use 3 resistors. So we have R1, R2, and R3. For this, let's say that we have a 60 volt supply, and R1, let's say, is 20 ohms, R2 is 30 ohms, and R3, let's make about 40 ohms. Okay, so we'll start off making a table. So here is our table: voltage, current, resistance, power. And then we have R1, R2, R3, and total. Okay, so let's start off with our steps again. So here's our steps. Step 1, the knowns. So we know that this is 60. We know we have 20, 30, and 40 for our resistance. Step 2, what's the same? We know that the voltage is the same because this is a parallel circuit. So that means that this would be 60, 60, 60. Next thing we're going to do for step 3 is solve for all the currents. So we have I1 equals V1 over R1. So that would be 60 divided by 20, so that's going to be 3 amps. I2 is V2 over R2, so that's 60 divided by 30, so that's going to be 2 amps. And then I3 is V3 divided by R3, so that's going to be 60 divided by 40, and that's going to be 1.5. And so we'd have 1.5 here. I total is the sum, I1 plus I2 plus I3. 3 plus 2 plus 1.5. And we get 6.5 amps for the total. Okay. Next thing that we'll do is number 4 here is find our total. So there's 2 ways to do it. So the first way that we'll do it is V total divided by I total. So we'd have 60 divided by 6.5. And that's 9.23 ohms. So this would be 9.23. The other way to find our total would be do the inverse of the sum of the reciprocals. We'll use the formula for that. So that's going to be 20 to the negative 1 plus 30 to the negative 1 plus 40 to the negative 1. And if we do that, we'll also get 9.23 ohms. The last step here is to find the powers. So we have P1 equals V1 times I1. So that's going to be 60 times 3. So that's going to equal 180 watts. P2 is V2 times I2. So that's going to be 60 times 2. So that's 120 watts. P3 is V3 times I3. And that's 60 times 1.5. And that's going to be 90 watts. And then P total is V total times I total. So that's going to be 60 times 6.5. And, whoops. And that's going to be equal 390 watts. All right, so let's go and check that on our spreadsheet. Okay, so this time on the spreadsheet, what I'm going to do is I'm going to insert a line. So I'm going to highlight these cells. I'm going to go insert, and I'm going to shift the cells down. Okay, and I'm going to grab this one and say resistor 3. This one I'll say equals the voltage here. This time we have different resistors, so let's get rid of those. And let's type in, we have 20, 30, and 40. Now The resistance, that's still good. Current, that's good, voltage divided by resistance. So let's grab this and we'll pull that down. So we have 40 divided by 30, that's good. 40 divided by 440, oh, just a minute, let's change this to 60. Okay, so when I did that, all my voltages are 60 now. The current, we wanted it to be the sum. We'll make that the whole thing, C2 through C4. Hit enter. And for the power, let's double click on that. And there we go. Okay, so if I look here, if I kind of go through these cells, voltage here, that equals the total. Voltage there, that equals the total. Voltage there, that equals the total. The resistance, we put those numbers in. So these are just the numbers. This one is B2 divided by D2. So that one's good. B3 divided by D3. B4 divided by D4. This one is the sum, so that's good. Resistance is voltage divided by current, so that one's good. And then these are voltage times power, or voltage times current, voltage times current, voltage times current, voltage times current. Okay, so that's good. All right, so let's look and see how does that match up with what we had for our table. And we look here, we have 63, 20, 180, 62, 30, 120, 60, 1.5, 40, 90. Yep, that looks good. Okay, so let's go back to the problem. Oops. And let's look at the current. So what is the current doing? So we'll do this one kind of in stages. What I'm going to do is, let's start off here, and the total current we have is 6.5, okay? And then what I want to do is, let's draw these currents in different colors here. So I'm going to draw this one as 3, this one as 2, and this one as 1.5. So that way we can see it a little bit better when we go up here. All right, so let's look here at the circuit and see what's happening. So 6.5 goes into this first node, and 3 amps are going to go up. So that means that the current that goes here is going to be 6.5 minus 3, which is 3.5, which isn't one of our currents. This is actually going to be I2 plus I3. Then when we get to the next node, we're going to have I2, which is here, which I'm going to draw that in orange, which is going to be 2, and then we'll have I3, which goes this way, which is 1.5. I didn't get the right color. Let me try that again. So that's going to be I3. So when we look at this wire right here is going to be a different current. It's going to be the total of I2 plus I3. And so when we get to lab, one of the things that we're going to have to worry about is how do we pick off the wire to make sure that we get the right current. If we're trying to measure I2, we have to pick this wire, which has I2, or this wire, which has I3. This wire has I1. This one is 2 plus 3. So we're going to be careful about that when we get to the lab. And then this wire, of course, has I total, which would be 1 plus 2 plus 3. And so depending on the how the wires are connected, we have to kind of pay attention to the currents for these circuits. Okay, so let's look at another example. And this one is going to have 3 resistors again. And this time let's make R1 10K, R2 20K, and R3 30K. We'll make the voltage supply 100 volts. Okay? So now what I'm going to do is put in the table voltage, current, resistance, and power. And I have R1, R2, R3, and total. Now for this one, I'm not going to do the problem. I'm going to cheat, and I'm going to go to Excel. I'm going to have Excel solve this one for me. So the total voltage, so I'll start off by putting in the knowns. So this is 100, and then this would be 10K, 20K, and 30K. So these are my knowns. So what I'm going to do when I go back to Excel is I'm going to put in the knowns. So 100, and then 10,000, 20,000, and 30,000. And what Excel is going to do, let's make this just a little bit neater. So I'll make this like that, and this like that. Okay. So now, let's do this one too. All right, so now in Excel, I have the answers, okay? So if I go over here, this was 100, 100, 100. And then if I grab my spreadsheet again, my currents, I have 10 milliamps, 5 milliamps, and 3 milliamps. So if I convert this to engineering notation, this would be 10 milliamps, 5 milliamps, 3 milliamps, and this is 18 milliamps. The resistance was 5,455, so that's going to be 5.46K if we round it. And then the powers here, we get 1 watt, 0.5 watts or 500 milliwatts, 0.33 watts or 333 milliwatts, and then we get 1.83 watts for the total. So Excel has solved this problem for me. So for practice, what I would recommend doing is solving this problem and see if you get the answers that we came up with. All right, so let's do one more problem. This time we're going to have some different things. So let's say that we have some resistors. So let's say that we have 3 resistors, and so we have R1, R2, and R3. And for this one, let's say that we know that the current going through this resistor here is 2 amps. We know that the current flowing here is 4 amps. And we know that we have, actually, sorry, let's make this 5 amps. And we know that we have the current here is 8 amps. And then let's say that this resistor's value is 10 ohms. Okay, so what we're trying to do is figure out what else we have for this problem. So can we find all of the other unknowns? So here we have voltage, current, resistance, and power. And so we start off, we have R1, R2, R3, and total. Okay, so what are we going to do for this problem? So the first thing, step one, is going to be writing in our knowns. So we know the total current is 8. We know that R2 is 2. We know that the resistance here is 10. Okay, so right now we don't have a lot. But if we look here, as far as our steps go, step 2, what we're going to try to do is figure out what we can find. So if we have 5 amps going into this node and 2 amps going here, this current is going to be 3 amps. So I3 is going to be 5 minus 2. So it's going to be 3 amps. So this is 3. Okay. Now we can figure out what the current here is. If I have 8 going in and I have 5 going out, then this must be 3 amps. Oh, geez, I wrote this in the wrong spot. This one should be 3, and then R1 should also be 3. Now this is a parallel circuit, so all of the voltages are the same. We probably should have did that right at the beginning. So this means if we know what one of the voltages is, then we can find the rest of them. And this was 3. So now what we can do, if we look at our table, is we have the current and resistance for this resistor, so we can figure out the voltage. So that's what we'll do next. We'll find V1, which is going to be 3 times 10. So that means that our voltage is 30 volts. Multiply these two together. So we have 30, 30, 30, and 30. Okay? So now, next, we can look at the number 4 here. We can look at the resistances. So we have R2, that's going to be 30 divided by 2, voltage divided by current. So this would be 15. R3 is going to be 30 divided by 3. So that's also going to be a 10 ohm resistor. And then our total is V total divided by I total. So that's 30 divided by 8. And that's going to be 3.75. And then lastly, we can find all of the individual powers. So P1 equals 30 times 3. So that's going to be 90 watts. P2 is 30 times 2, so that would be 60 watts. P3 is going to be 30 times 3, so that's also going to be 90 watts. And then P total is 30 times 8.75. And that's going to be, back up. 30 times 8. And that's going to be 240 watts. Okay, so let's double check that over here on our formula. So on our Excel, now this spreadsheet is set up to put in the numbers this way, so I'm going to put these numbers in this way. So I'll have 30 for the voltage, and that'll make all the voltages 30. And then resistors, I have 10, 15, and 10. And let's see, how did it come out? 3, 2, 3, 8, 90, 60, 90, 240. Looks like we did it. All right, so that is the last one that I want to do. So that's the end of this video. Thank you.